So we started working with hierarchies and subclasses and superclasses last time. We're going to talk about a little bit about just constructors now. And I have to tell you, constructors are not inherited. So if a parent class has a constructor, and then you have a child class, the child class doesn't have that parent constructor. Turns out we do inherit everything else. Thank you. But not the constructors. So, and we did this, what I'm about to say last time. You can call the parent constructor using the supercall. A supercall has to be the first line in your child constructor. And here's the kicker. If you don't put a supercall as the first line in your child constructor, Java calls a no argument supercall as the first thing in the constructor. It's going to call a constructor. Either you're calling super with the parameters you want, or Java's going to call one that has no arguments, which may or may not work. I'll show you with an example in a minute. So it's kind of like it's going to happen one way or another. Some classes don't have a no argument call. Like whenever we've had a student class, we haven't let you create a student without sending over a first name and a last name, right? Because it seems a little silly to even bother saying, here's a student object, but they have no name, you know. I mean, I guess there could be a reason to do that, but so if we had a student class and you had to give a first and a last name to create the student, then there would be no there would not be a no argument constructor. But some classes allow you to have a no argument constructor where you create this thing and you just you send it over with empty parentheses and it creates the object without any data that you sent it. Everybody, I'd like you to go onto the website and download day 64 example 1. So we're gonna look at a little thing here. Day 64, example 1. Just download it and open it. And with luck, it will compile. You're not going to turn this in. It's not an assignment, but you should open it up and I don't know, do a Control-R, make sure it works. We'll take a look. Yeah, so it's working. It's good. So, what we've got here, let's take a look. I made a class called Class A. It has a number integer variable, and it's got a no argument constructor. See this, where it says Class A with nothing in the parentheses? And when you call a no argument constructor, it says no argument constructor, called. And it sets the number variable to -1. And then otherwise you can call it with an integer, and then that's a different constructor, so it calls the integer constructor. So it's kind of a silly class. It doesn't do anything, but it allows us to see a relationship. If you scroll down a little bit, we've got Class B extends Class A, and I made two constructors in Class B. The first constructor is the no argument constructor. It says no argument constructor in B executes, and the one argument constructor in B executes. So let's go back up to the top, and you'll see here I made a Class A object called A, and I made it without any arguments. And I made a Class B object called B, and let's see. And I'm not printing the objects or anything. I'm just creating them. So when we run this, let's look at what is output. and see if it makes sense to you. When we create a class A object, this line that I've highlighted up top, I just say new class A, and I print it out. I'm creating a no argument class A. So it says creating a no argument class A object, and then what gets printed is the no argument constructor in A. So back down to the code. When we say we're going to make a new class A, it comes right here. There's no arguments, so it runs this code right here, and it prints out that line. Now, when we create the class B constructor, did you see the output? 2 lines get printed. When we create the class B object, again, we're creating it with no argument here, a new class B right here. Look what prints first. It says, hey, the constructor, the no argument in constructor in A executes, and then the no argument constructor in B executes. What really happens is Java finds the B code, comes right here, it says, okay, we're going to do the no argument constructor. But then it says to itself, hey, this is extending class A. I've got to run the parent no argument constructor first. So right here, kind of like right here, there's an invisible supercall. Because then it hops up here and it prints, hey, we're doing the no argument class A. And then when that's done, then it says, hey, now I'm doing the no argument class B. And so you don't, watch, I think if I wrote super with nothing in it, we'd have exactly the same behavior. So, I mean, that's not going to change anything. Yes, so it's running the no argument constructor in A and then the no argument constructor in B. You can't get around it. When you have a child class, it's going to call the parent constructor one way or another. Either you're calling it or it's going to call it for you. And when it's a no argument constructor, it doesn't matter. Just let them do it for you. No problem. But when there's possible arguments, you need to send the right arguments up to the parent. And we're going to do that next. So let's come up to the top here and uncomment out these next 2 lines where it says creating a class B object with an argument. So see, we're creating another B object. It's called BB, and we're sending over 3. And let's see what happens here. We only care about the last lines. So when we're creating a class B object with an argument, in my current setup, it runs the no argument constructor in A, and then it runs the one argument constructor in B. So let's go down and take a look. And that's because when we call this class here, when we call this constructor, it's calling this one because we sent over the number 3. There's nothing written here, so it calls the no argument parent constructor. It's like saying super with nothing in it, and then it calls, and then it runs this code right here. So actually what's interesting is the number. Let's comment out this last line here where we print out the number. We're going to get the number that's stored with the BB object. So let's run it now. Let's see. Did I get rid of get num? I guess I did. Get rid of that. Forget that. Delete that line. Pay no attention to the man behind the mirror. All right. So what I want to do is go down to the B class. Because if we want to store this number somewhere, right now it's just getting thrown away. The way to store it is to make a super call and send that number up to the parent. This is an example of where we'd want to add a super call because we're getting a number. This integer is getting sent over. It's the number 3. And we want to send it to the parent because it's up in the parent that number gets stored in the num variable, and then we can use it later for whatever's going on. So I'm asking you right now down in class B to add this super parentheses n. And then we'll run it again. And the last line here, see it says creating a class B object with an argument. And look, instead of the no argument constructor, we've got the int constructor in A executes. And then it executes this print line. The int constructor is this one. because we called super with a number, so it calls this one, and it sets the number to that number, so it's stored. That's the kind of thing. We were doing that with I don't think we had, no, I don't think, did we have to do that with the shapes on Monday? I can't remember. Super. Or we sent the color up. Remember, we were setting the color of the shape by saying super with the color. And that sent the color up to the parent. So this is what that super call does. Questions? Don't worry, you'll get to practice. All right, we can close that. Back to our notes. That was it for 9.2. So now we're going to do 9.3. 9.3 shorter. So, we're going to talk about overriding methods briefly. It's important to know that subclasses inherit all public methods from their parent, from the superclass. The trick is we often will override parent methods. So we'll often override parent methods in the child classes to access the new functionality. Like, let's say we had an automobile class, and then we had an electric car class underneath that. Electric car has like a level of charge you'd want to know before you drove somewhere. If you didn't override the toString or add some method that lets you get at the charge level, it would just say it was a car. You know, like, oh, I'm a car. And you're like, yeah, but I want to know the charge. Well, you need some methods in the child class. Maybe you change the toString method so you can get it. But the parent class doesn't know about electricity. It just knows it's a car. And the child class, that's where you added functionality. So sometimes it involves overriding methods. We were overriding the toString method on Monday in a child class so that you could see the additional information. You could just print it, and it would call the parent toString, and it would just say, hey, I'm a shape that's pink. But instead, we were adding more information so we could get at the new stuff we added. And here's the last point on here. A child class overrides a parent method when a method has the same name and signature of a parent method. So, like public string toString or any other method has to be exactly the same parameters and name. And I think you'll know when you're overriding a method. I mean, I don't think that happens by accident. So that's it for 9.3. Told you it was quick. Any questions? A lot of this will make more sense as we work with it more, and that's what we're going to do when we're done with the notes. So now 9.4 is the super keyword. So, you're with me here. As we just discussed, the super keyword allows a child class to call a parent constructor. It also allows a child class to call a parent method.
Doesn't it call automatically?
It will call it automatically, but if you overrode a method in a child class, you can still access the unoverridden method by using the super call. I know I just said children inherit all public methods from their parents. which is great. So you don't need to use the supercall unless a method's been overwritten in the child. And then if you called like toString, it's going to get the child toString, not the parent toString. But if you want the parent toString, and you're going to do something to it, and then, as opposed to the child toString, then you can use super. So it allows, let's see. Sorry about it, also allows. So this is what I just said out loud. Because all parent methods are public, you only need to use the supercall to call a parent method that a child class has overridden. So let's go open up day 64 example 2. And you'll see what I'm talking about. Okay, so we still have our class A, class B, but I changed them around. It's different code, and I was trying to keep from making that one class be too big to deal with it. I added, let's take a look. We still have that num, we have the no argument constructor, but I took out those print calls, that were telling us which one was running. But also there's a get num thing, but there's also something called say something. And a class A object says ah, and a class B object says boo. So if we go up here and we run this, I'm creating an A and a B, and then I'm calling say something on everything. So let's see what happens. And I'm also calling get num, apparently. So when we call say something on a class A object, I get ah, and I'm calling say something on a class B object, and I get boo, and I'm calling get num on these things, and I get my -1. I'm not even sure why the get num's there, so let's not worry about that. But if I wanted to call like say I wanted to get the parent say something, I could right here say super dot say something. This would be using super to call the parent method. So we're going to get both when we get the B. So when I do the B now, first it says ah because it calls the parent, and then it calls boo for which was what was already there. This is what this is doing. Otherwise, just doing say something is just going to do, the one in the child. I know why the get num was there. Check it out. The class B doesn't have a get num, so I was showing you how it inherits. Right here we have class B extends class A. And notice there's no get num method in class B. I mean, it'd be easier to see on your screen. There's no get num in class B. There is a get num in class A though. And so when we're up here, if I call get num on a class B object, right here, I'm seeing b.getNum. You might be thinking, wait a minute, you can't do that. There's no getNum method in here. But remember, we inherit all methods from the parent. And we had one called getNum in the parent class. So you can call a b.getNum, and it goes ahead and calls it. Here's something else. If we get rid of this say something in the B, what will happen when we run the code? It'll work.
We'll say ah.
Yeah, it'll say ah. Because remember, we inherit all the methods from the parent. So here we are calling say something on a class B object now, and it says class A object says ah. So it's a little misleading now, but the point was, if you're you get all the methods from the parent, and then sometimes you overwrite them. That was what I was trying to get at here. Questions? That was a lot to process.